all fine? Okay. So I will make this here. So officially welcome everybody here. It is my pleasure to have here Professor Carroll, that you may as well very well known. He's currently in Johns Hopkins University. He works in many things, in quantum field theory especially. And we had the pleasure of hearing 2 days ago his talk. And let me remind me of the title of the talk. Quantum field theory and the limits of knowledge. And I think something that will be very interesting to hear about himself is that he has a very strong opinion about the nature of reality in everyday life. So for him, we already know everything. I mean, all the laws of physics that we know of can explain whatever we experience in everyday life, right? So that's something that can be debatable, right? But in today's conversation, I think we want to explore like all the possible topics that can be talked about surrounding the nature of reality. And I brought up a set of questions that can guide the conversation, but please feel free to like contribute with any other questions you can have in between. We can go through one by one. And I think I will, for a beginning, I would like to like pose a question and hear your opinion, Sean, if you are happy to, and then we can like lead up to whatever comes next. What do you think?
That sounds great to me.
Perfect. Yeah, we just have another person coming. Welcome. So the first question that I have here is, does the universe exist without an observer? And I really want to hear your opinion, Sean.
Well, like I said, I don't know the answer to these questions, but I do have opinions about them. My opinion about this one is, of course it does. I mean, why in the world would we be so arrogant as to think that somehow the universe cared about whether or not we exist there? I do think that the universe becomes interesting when it has observers in it, because then you can start asking questions about what does one part of the universe look like from the perspective of the other part. And I think especially when you get deep into quantum mechanics and the emergence of space and time, that becomes a very relevant way of thinking. But I don't know of any sense of the word existence in which the existence of the universe itself depends on the existence of observers. And I'm not even sure what the argument for that would be. It's hard because we're all observers. So we have our prejudices and our biases based on that part of our own experience. It's hard to imagine what we would be like if we were not observers. But nevertheless, the physical reality out there doesn't seem to care much about whether or not we're observing it or not.
Anyone has an opinion about this and wants to comment and ask a follow-up question? Okay, I see somebody here.
Oh, wow, I was only thinking, but
now
you put me on the spot, Sophie. No, I think that's pretty much unarguable. But I guess you're also, when you're thinking about the universe in the absence of observers, you're thinking about that from an observer frame of reference, from like a third-party frame of reference. And I guess that's why like people still get hung up on the question, is because it's impossible to imagine observing observer absent universe. But yeah.
Yeah, and I think that, like I alluded to, quantum mechanics does make the question a little bit less trivial. In classical mechanics, there was no one was going around thinking, actually, that's not even true, but scientists were not going around thinking that the universe cared about observers. There were and are views in philosophy in the idealistic tradition, where you put mind at the center of the fundamental nature of the world. But scientists generally don't sign up for that. Some of them maybe do. But quantum mechanics did make it more difficult because, at least in the laws of physics, there now seem to be special laws for when things get observed. Wave functions collapse and entanglement is broken and things like that. There are various formulations of quantum mechanics. Many worlds is one of them, but also hidden variable theories, objective collapse theories, in which there's nothing special about the act of observing whatsoever. And so you once again remove the observer from the equation, but at least you can be sympathetic to why someone would have believed it 50 years ago, before we really had thought about this stuff very much.
Because is it fair to say that in a world in the absence of observers, the measurement problem is no longer a problem. And so from the perspective of quantum mechanics, a universe without observers is very simple, very easy to mathematically understand and so forth.
You know, it's hard to know about that. I mean, there's the amusing historical fact that Hugh Everett, when he was a graduate student at Princeton, was given the project for his thesis by his advisor, John Wheeler, to quantize gravity. They didn't know that it was hard back then. We still haven't done it. But he started thinking about it. He made zero progress in quantizing gravity, but he thought deeply about the fact that if you're taking the whole universe as your quantum system, then there's no observer outside. And so you can't use the conventional quantum mechanical formalism. And that led him to invent what we now call many worlds, what he at first called the theory of the universal wave function. That was his name for it. In some sense, there is a simple description of the universe if you don't need to worry about what observers see. That's what I was alluding to when I talked about the universe becomes interesting once you start saying, well, what does one part of it observe or measure or experience with respect to the other part? It's the sort of relationships inside the universe that are complicated. The universe itself is relatively simple, if Everett is right.
And I have a follow-up question, because why do we define measurement observer as something so sophisticated? Isn't it not just a fancy way of saying interaction, right? It's not just an observer, something that interacts with the system. It's anything fancier than that. You know?
It is something a little bit fancier than that. You know, again, in the early days of quantum mechanics, we had to talk about measurements because the data seemed to imply that objects behave differently when they're being measured and when they're not. We have a more sophisticated view of that now, where it really has to do with entanglement. When one system becomes entangled with another quantum system, and in particular, when a quantum system becomes entangled with the entire rest of the world, that's what we really should mean by a measurement or an observation, and has nothing to do with consciousness or agents or thinking or looking. It's just when the environment of the world becomes entangled with the system. But it's not quite the same as interaction. If you take a spin that is in a superposition of spin up and spin down, if I measure that spin, what I mean is I entangle it with myself, so that the spin up part is entangled with the part of me that saw it spin up, and the spin down part likewise. But I can take that spin and I can just drop it in a gravitational field. And the spin up and spin down parts fall in the gravitational field at exactly the same rate. So that is an interaction between the spin and the Earth's gravity, but it's not a measurement because nothing's getting entangled. The whole thing is just moving in the same way. So that's a little bit of a difference.
Any other comments around here, or online? Anyone online wants to contribute with something? Last time before we move on. Okay. People are very quiet.
They're afraid.
No, come on. I don't think they shouldn't be, right?
They shouldn't be. I'm not very
Or they
scary.
should.
No, they should not.
I mean,
They
this
should
is
not.
a chance, right? To interact with you in
I
this
know.
more relaxed way, right?
Yeah.
Take the chance. Okay, maybe let's go to the second question. Is the nature of consciousness defined as part of everyday life? Or, I mean, could we explain by a very known physics?
Right. So again, my opinion here, and here I think I have more backup for my opinion. What I'm trying to say is that everything that goes on physically and biologically in your body and your brain, by the standard conventions of ordinary science, is very, very well within the everyday life regime. Okay, you can literally quantify it in terms of the scattering energies or the energy transfer when there's an interaction inside a chemical in your brain and whatever. You can compare that to the domain of validity of this effective field theory, and everything that happens in us is very, very much in the everyday life regime. Furthermore, I think that consciousness is at least related to physically what happens. In fact, I think it's nothing more or less than physically what happens, but there are some people out there who want to say, sure, okay, that's true about the physical stuff in your brain and your body, but consciousness is a different kind of thing. And my point is that I hope you think that whatever consciousness is, it interacts with your physical body. I mean, part of what my physical body is doing is it's talking about my conscious experiences. If someone says to me, I'm experiencing sadness or I'm experiencing the redness of red, either that speech act is physically connected to the conscious experience, or I have no reason to believe that. If those two things are not connected, then they're completely unreliable. Even I am unreliable when I say it, because there's no connection between the physical reality and the consciousness. So if you want consciousness to be something other than emergent from purely physical stuff, you have to change the laws of physics that govern the behavior of the stuff that you and I are made out of. I think that the presumption against doing that is enormously big. And so the fact that we don't understand consciousness, while important, is nowhere near probative enough to say you should mess with the laws of physics.
Actually, I have another suggestion. I mean, I'm thinking, for example, that first of all, it's very arrogant to say that consciousness has to be something different, right? Because again, we are the humans experiencing the world and having the consciousness, right?
Mm-hmm.
So
well, look, I mean, sorry, I say yes, but I don't know what is arrogant and what is not. I mean, is it arrogant? There's plenty of people who will say that it's arrogant to say that consciousness fits in with the laws of physics. So I don't understand what the right way of arrogance is. I'd rather care about what is the true way and what is the not true way.
I mean, if this is true, I mean, if your opinion is true, that means that actually there can be a future in which machines can, if we made them following the same principles as we understand consciousness, can develop consciousness themselves, right?
That is true. Yes, there should be no obstacle to that whatsoever, right?
Yeah, because then you will have a very nice debate with the previous speaker.
Yeah, I don't know. I don't actually know what Christoph's view is. Does he not think that computers can become conscious? I thought that he could. I thought that he said that they would, but I don't remember. It's been a long time.
I think he was like more into they don't, because yeah.
Okay.
I don't remember the exact argument why, but that's what it would have been nice to have him here, because I cannot remember.
I thought he was a panpsychist, so he thinks there's a little bit of consciousness everywhere.
I mean, he has this like phi number where it defines complexity that
right.
He measured consciousness, but it's still debatable, if that's like a true measurement of consciousness, because there appears to be systems which, by any definition, you wouldn't believe they are conscious. Like, I don't know, I think electrical grids or things like that, and they have a very large number of phi, so they're supposed to be very aware or whatever, very complex.
That's complicated, right?
But anyone has any other comment with respect to this? Okay.
So this is just a quick sort of clarification, I guess. And it's not necessarily related to consciousness, but as you've probably seen, there's a bit of a renaissance of quantum biology these days. So there are some systems, like magnetoreception, cryptochromes, and also like coherence between different regions of a protein and that kind of thing. So I just wanted to quickly get your opinion on whether, like, if, for example, we find that some of these biomolecules are taking advantage of entanglement and that kind of thing, that's still well within the realm of the well understood, like, explainable physics that you refer to as the physics of the everyday world, right? So that kind of quantum biology is still totally fine with respect to everything being predictable in everyday life.
Very, very much. But, it's not the word predictable that I would use. What I would use is compatible with the core theory of physics. Whenever it gets to pragmatic considerations of how to derive things or predict things, etc., as soon as you have more than a couple particles moving around, that becomes incredibly hard. So I don't want to make too much of an emphasis on that.
Yeah.
online. You can type questions in the chat if you want. So yeah, if you want, I will move to the question that I wanted to ask because I think you didn't mention anything about it in your talk.
You're very quiet. Sorry.
Yeah, I completely forgot. Okay, now you can hear me. Yes.
Yes, I can.
I was saying that this question in particular, I wrote it because I think you didn't mention this in your talk, and I'm very mesmerized by this Gödel incompleteness theorem. I think it's something apparently fundamental, not just of mathematics, but reality. So, and I think it's related to the question if actually we can find a fundamental theory of everything, right? Because if this is correct, and apparently appears to be true, there's no way to like actually verify anything fundamentally, right? I don't know what your views are with that. Yeah.
I think it's not exactly that. I mean, I think Gödel's theorem is certainly a mind-bending result in mathematical logic, and it's very, very important, and it's worth trying to come to grips with it. But I think there's a very precise statement of it, and it's a little bit too easy to sort of define the words or extend them beyond their meaningfulness. What Gödel's theorem says is if you have a sufficiently powerful mathematical system with axioms and theorems and definitions and so forth, then either that system is inconsistent, so you can prove that 0 equals 1 and then you're in trouble, or there are true statements that you can state in that system that you cannot prove at all. That's what the theorem says. That's it. And so I personally don't see any reason at all that this would imply that no finite mathematical can capture physical reality. Because what you can do in a finite mathematical model is generate true statements. You can't generate all of them, but the physical world doesn't need to be every possible configuration of stuff. The way the physical world works, as far as we know, is there's a configuration of stuff at any one moment of time, and then the laws of physics tell you how it evolves into another configuration of stuff at the next moment of time. And there's just no obstacle from Gödel's theorem to that working forever and completely in the whole universe, nor to us discovering what that physical model is. There might be other obstacles to finding the complete theory of everything, but I think the Gödel's theorem is not among them myself.
Mm-hmm. Then do you imply that basically like reality is just like a subset of like a mathematical model that can describe it? So
I don't think that way myself. But I haven't thought about this very deeply, and there are other people who have, so I don't want to claim too much expertise here. But in my mind, I distinguish between physical reality and the mathematical description of physical reality. So the reality is all by itself. It's sui generis, as the philosophers would say. It's a unique thing. If you want to ask what reality is, it's reality. That's what it is. It's not made of anything else. It's not, related to anything else. It's just all of reality. And we can use mathematics to talk about reality. We can take parts of it and we can model them using mathematics. But what we can and cannot do with the mathematics is separate, a separate question from what reality is and is not going to do. So, I'm not on the boat of like Max Tegmark, for example, who says that reality is mathematics in any way. Reality is reality. Mathematics is a language we use to talk about it.
but then what is reality? I think that's like a problem.
I don't think that's a good question. Reality is reality. That's the answer.
I think that's something that you also mentioned in your talk. Like one part is like mathematical models that describe reality, and the other are the interpretation of those mathematical models. And that, I guess your statement is that we don't care about interpretation, right? As long as we can predict or describe reality.
No, I would think we might care about interpretations a lot, but we shouldn't mistake them for the reality itself. The model is not the reality. The map is not the territory. They're both interesting things, and you want your map to be as accurate a model of the reality of the territory as you can, but the territory is still the territory. Reality is still reality. It doesn't care about your math.
Anyone? Yes, Ben? No? Really? I don't want to like just speak for myself, guys.
Go
I
ahead,
will
Sophia,
be
do
like-
all the talking.
I mean, I don't mind for you say all the talking, but I don't want just to ask the questions here. So, okay, come.
Because you know, one of my favorite topics is emergence, and but I get chastised by philosophers for using the word emergence, and they say, "Come on, no one takes emergence seriously." The philosophers already decided years ago that emergence is like wrong essentially, and you should use the word complexification instead. And I come back and say, okay, this may just be a semantic issue, but at the same time, I can tell you that a lot of people in a few different fields are still using the word emergence. I think they're mainly worried about top-down causation. But so the question I wanted to ask though is, given that we have, on the assumption that we have all the theoretical tools to understand the physics of everyday life, does that then imply that a theory of everything is a theory of emergence? Because if such a thing were to exist, that seems like what we would need to have a theory of everything. And you know, when we talk about this idea of a unified, you know, quantum gravity being a theory of everything, it always confuses me because I feel like that's just a theory of a very narrow subset of physical phenomena. It's a theory of very little, actually. So yeah, do you think comprehensive understanding of emergence would qualify as a theory of everything?
So I can't actually see anybody in the room there, but that's got to be Stuart, right?
Right.
Hi, Stuart. No, I think that these are all very good points, but I think that they're almost entirely semantic issues, like you suggested. I was also told, I wrote a whole book called The Big Picture, in which I use the word emergence like on every page. And I was told by my philosophy friends and also my sociology friends, don't do that. It has a meaning, and it's not a good meaning. In fact, it's kind of what it means in our fields is exactly the opposite of what you want it to mean. Because to me, what emergence is a set of ways of talking about higher level collective behaviors that are importantly compatible with the microscopic behavior, but so there's nothing new there, but they're very, very useful summaries of what happens at the microscopic level.
Right.
Whereas in certain dark corners of the philosophy literature or the sociology literature, emergence literally means the opposite, that there is something brand new that is not reducible, not predictable, not even compatible with what happens at the lower level. And so sometimes this is distinguished as weak emergence versus strong emergence, but even then people will debate what those two things mean. And so I did actually try hard to think of a new word, but you know, new words also have their own connotations somehow. And so I didn't succeed. So I'm still using emergence, and I'm just trying to beat people into, you know, I've had talks, I've talked with people who are strong emergentists. So for those of you who are not familiar with the lingo here, strong emergence is literally this belief that there is something that happens, like if you took the fundamental microscopic laws of physics and put them on a computer and tried to use them to predict what would happen in some macroscopic system, you would get the wrong answer because the macroscopic system is strongly emergent, is fundamentally different. And so, you know, I tried to have discussions and I would say, well, like, let's consider a very, very simple example of emergence. And I would give a simple example and they would say, well, but that's not emergence because, yeah, that's too simple. I can understand that. I think that there's a certain set of people who want to reserve the word emergence specifically for things that they find hard to understand. And it's sort of like the opposite of my physicist's intuition, where I want to go to the simplest case and try to understand it the best I can. So I'm still stuck with the old word. As far as the theory of everything is concerned, I think it's almost exactly the same issue, but kind of pointing in the opposite direction. The phrase theory of everything became common or popular when string theory really hit the market in the 1980s, really had a boom. And literally by everything, they just meant all of the fundamental laws of physics. In particular, they had in mind that we already knew the electromagnetic weak and strong nuclear forces, and we were finally getting gravity into the game in a single grand unified thing, and we're going to call it the theory of everything. It was never meant to imply that we would understand all of the higher emergent levels. No one ever thought that the theory of everything in that sense was supposed to cover chemistry or biology or sociology or psychology or economics or urban design. It was supposed to be compatible with all of that stuff, but that's all separate knowledge from the theory of everything. So if you want to fight the battle to, make a better nomenclature for that, go ahead. But even string theorists these days are not that quick to use theory of everything to describe their own field. So I don't think you're pushing against an open door for the most part.
And what's your feeling for theories of emergence? Is that
I haven't seen. I'm not satisfied with current definitions of emergence, even if we're just sticking to weak emergence. I think that we're handicapped by kind of knowing the answer. Like I have a desk in front of me and it's in some way it's emergent from the underlying laws of quantum field theory and the standard model of particle physics. So I end up inventing definitions of emergence that say like, well, desk-like things will appear, but the overall general super duper encompassing theory of it, I've not heard a good proposal for it. And every time that I hear one, like you can come up with a counterexample, it doesn't quite fit. So I think that's still a good open question. There's been plenty of ink spilled about it. It's not like no one has tried. And maybe there is one out there that I just don't know about that would convince me. But to me, I still want to try to do better.
Thank you. Okay, I guess we can move to the next question unless somebody wants to get animated online and contribute something or ask a question. Yeah, Dao was talking before, so I'm pretty sure could ask a question if you want to. You are Dao. I'm sorry. Okay, sorry.
Right. So on this topic of emergence, I'm interested in how we can think about. So it seems like on more macro level, on the more macro level, let's say in economics, right? There seems to be some kind of human agency going on, right? We can decide whether we opt for, let's say, more socialist policies or more capitalist policies to structure our lives. How is that compatible with the more micro fundamental physical level? And so it seems like at some point there's a switch, some agency comes up. Is this really just an illusion? And this illusion can be explained by the lack of a proper theory of emergence, or is there really something going on?
Well, I wouldn't call it an illusion. This is yet another word that is bandied about that different people disagree about different things. If I think that the table in front of me is an emergent phenomenon made of atoms, that doesn't mean it's an illusion. The table is really there. And to me, human agency is exactly the same way. But this gets into the question of free will and compatibilism. So even if we lived in a completely deterministic world, which we don't because there's quantum mechanics, but even if we did, there's a long tradition that tries to understand how the best way of talking about human beings is as agents making decisions, even though if you knew all the fundamental laws of physics and the complete state of the universe, you could predict exactly what a human being would do. And it's based on a very simple observation, namely that you do not know the complete state of the universe or all the fundamental laws of physics. The fact that we are obeying the laws of physics, and therefore we're either deterministic or at least predicted by the laws of physics, is irrelevant to everything we actually do as human beings. And the choice is, if you want to say, well, at the fundamental level, everything is just obeying the laws of physics, fine, then only describe things at the fundamental level. Never talk about people and desks and things like that. Only talk about protons, neutrons, and electrons. And I think you will find it is very hard to get very far in life. It is much more useful to talk about human beings. even though they don't exist at the fundamental level. And when you talk about human beings and you're describing what human beings are like, you will, again, as part of your best possible description, include those human beings having opinions about things, having feelings, having values, having desires, and making choices. That's just a feature of our best description of human beings as emergent creatures. And I think that's what agency is. The word agency is a way that we talk about this higher emergent level that includes human beings. It's not an illusion, but it's not something that is in any way violating or incompatible with the fundamental laws of physics either.
I don't know if you hear, but you said thank you. Okay, anything else? No? Should we go on? Okay, so I hear another question that I actually really want to know more about your opinion, because something I know, but I don't understand very well. So what are the implications of quantum particles breaking local realism? And that's related to these Bell's inequalities that were proven to be true, right? In the quantum realm, right?
Right. I mean, to be
yes.
super duper technical about it, it was proven that Bell's inequalities are violated. The way that he wrote the equal sign was that quantum mechanics violates them, which means that, yes, that you cannot be naively locally realistic. And this is a subtle question, but I actually want to turn it on its head a little bit, because as I've mentioned, my favorite version of the fundamental theory of quantum mechanics is the many worlds theory. And there is an assumption in Bell's theorem that says measurements have unique outcomes. When you measure the spin of a particle, it's either spin up or spin down. That is not true in many worlds, because in one world it's spin up and in the other world it's spin down. Measurements do not have unique outcomes throughout the wave function of the universe. So if you're just strictly speaking and being pedantic, Bell's theorem is irrelevant to many worlds. It's neither true or false. It just doesn't apply. However, that still leaves open the question of, is physics local in some deep sense? And my favorite way of thinking about many worlds, the answer is super duper clear, which is no, it's not local at all. Wave functions are not functions of space. They're functions of something else, configuration space or momentum space or something like that. So the old-fashioned classical point of view that you could think of the world as particles with locations and fields with values at each location is just wrong. The real question you should be asking is, why does the world look so local at all? I mean, the weird thing from a many worlds perspective is not how there can be these subtle violations of locality, but trying to explain why locality is such a good approximation in the classical regime. And even more than that, why you can't send signals faster than light and so on. That's the puzzle. And I think that's a very good puzzle, an important one. And no one asks it because they're just presumed that the universe is pretty local. And what they have to explain is the non-locality. I think it's the flip side of that.
What's your view on that then?
I'm working on it. I'm trying. I think that, you know, somehow the laws of physics have evolved to make a classical approximation with local laws of physics really, really a good approximation. I don't think it had to be that way, and I would like to know why it's true and how true it is.
You also mentioned that you really like the many worlds interpretation, and there's something I kind of never understood about it. It's like, for example, in that interpretation, the collapse of the wave function doesn't exist, right? It's just like there are two different worlds that happen. That one is like, for example, spin up or down, but it's like those two universes diverging. So like another full universe is created out of a previous one, or all the worlds existed already and they were just identical until that point. What physics says about that, you know? Well,
this is, I mean, I think this is an excellent question, and I have an answer to it, but it's not going to be a satisfying one. You know, look, if you know about Laplace's demon, Laplace's demon was the thought experiment from 1800 where Pierre-Simon Laplace says, if a super intelligent organism knew all of the positions and velocities of all the particles in the universe, it could predict exactly the future. So Laplace's demon doesn't exist, but if he did, he would not need to have higher level emergent descriptions, right? Laplace's demon doesn't need to talk about desks and people. Laplace's demon knows every atom. Laplace's demon doesn't talk about temperature or density or pressure. He literally knows exactly the microstate, okay? Or entropy for that matter. So the branches of the wave function of the universe, the worlds into which we divide the wave function of the universe, are like that. They are higher level, convenient things for human beings to think about, just like entropy and temperature and so forth. And as a result of that, there's a little bit of freedom in how to do it. They're not baked into the fundamental nature of reality. If there was a quantum Laplace's demon, it would just keep track of the wave function of the universe. It would never talk about branches. It doesn't need to. But we do, because we're tiny little, very, very bounded rationality creatures. And so the idea of branches is very, very useful to us. When it comes to the question of, should we think of the branch of the universe before some measurement event happens and you branch further as just one world or two worlds that are identical to each other, the disappointing answer I have for you is go ahead either way. It doesn't really matter. There's no physical right answer at the end of the day, as long as it works for you and is compatible with the experiments and the predictions, then it's fine. So I think that there's a very similar question to that, which is if I do a measurement right here, does the branching happen instantly throughout all of the universe? Or does it kind of propagate out at the speed of light or something like that? And again, the answer is it doesn't matter. The branching is something you invented for your own convenience. It's like a coordinate system or something like that. It's not there in the universe. So however works for you, whatever floats your boat, that's the way you should think about it.
So, if I understand correctly, if there was like branches, that there's no way they can interact with each other because it doesn't matter. Yeah.
Well, it's super, super, super duper unlikely that they will ever interact with each other. It's not 100% impossible.
And what about a universe before the universe? You know, like this series that there were previous universe creating this universe.
I like those theories, but I don't know whether they're right or not. This is, something that is perfectly respectable to speculate about and to think about. There might even be principled reasons for doing so. But the short answer is we don't know. Maybe the universe had a beginning. Maybe there was a moment before which there were no other moments. Also, maybe the universe is eternal. Also, maybe the concept of time is just a useful approximation and is not actually even relevant at the beginning of the universe. So we're thinking about these things. We have very little data to guide us. And so the answers are hard to come by.
I have a lot of related questions. I don't know if anyone wants to ask something because I have to ask so many things on your perspective.
Don't let them. Go ahead, Sophia. Don't listen to them.
Yeah, for example, the perception of time, right? Like we feel like an arrow of time, but that's because our consciousness has that, let's call it illusion. I don't know.
Yeah.
But it's like that intrinsic property of the universe to be evolved. Also like the entropy is increasing like every single time, right? And
yes,
that compatible with like what we understand as fundamental. It's so weird that there is a quantity that is increasing continuously, right?
Yeah, it is weird. I've written books about that too. And I think that it's crucially important and if anything, underemphasized. I think that the fact that entropy is increasing is at heart the explanation for all the different ways in which the past and future seem different to us, including the fact that we seem to think that time flows, including the fact that we have memories of the past and not the future, including the fact that we think that our actions today can affect the future, but not the past. These are all ultimately higher level ways we have of thinking about the universe in a world where entropy is increasing. But there's no law about how fast entropy is increasing. It is increasing. Anyone out there who is a biologist or anyone who works on psychology knows that increasing entropy is important for life. There's this misapprehension I think a lot of people have that somehow life, living organisms, fight against the increase of entropy of the universe. But it's exactly the opposite. living organisms depend sensitively on the increasing entropy of the universe. That's where they get their fuel and their ability to collect information and metabolism and organization and all of those things. If we lived in thermal equilibrium, none of that would be possible. And it has a lot to do with free will and human consciousness. We can remember the past, we can't remember the future, but we carry with us in our brains predictions for what the future will bring, especially like very, very near-term prediction. When I move my hand, I will hit the desk or whatever. And my brain is constantly updating its image of where I am now with its prediction of where I'm going to be next, plus some sensory input. And all of that feedback loop has to do with why we think we move forward in time. And I can recommend good people to talk to other than me if you're really interested in this stuff.
I mean, it seems like you don't only predict the future, but you predict the past.
Well, I would say you remember the past, sometimes inaccurately, but we think we have records of the past in a way that is distinct from the future. We have photographs, we have pieces of information that are very, very specific about things that we think are true in the future, things that tell us something about the past, which the macro state of the current world would not otherwise have been able to tell us. So we can predict and retrodict simple things like where the Earth was or where the sun was in the sky on different days. But what day a certain volcano erupted is not something we can predict in the future. It's too hard. And it's not something we can retrodict in the past unless we have a record of it. You know, someone wrote down on a piece of papyrus or took a picture of it or something like that. And we only have that capacity toward the past, not toward the future.
Hi there, I'm Becca. I hope you can hear me. I'm not literate in these topics at all, so I'm sorry if this is a silly question. But in some theoretical situation where the universe reached an equilibrium in entropy, would we be able to perceive that since our consciousness perceives this forward arrow of increasing entropy? Or would we cease to exist or something like that?
You got it. We would cease to exist. There would be no we. The whole idea of a person, again, if you think that the physical processes in our bodies and brains have anything to do with being a person at all, they really rely on the fact that we are out of equilibrium. Like if we were, for one thing, if we were in equilibrium, everything would be perfectly smoothly distributed. There'd be no like person here and no person there. There's just a thin gruel of stuff. At a more, excuse me, slightly more sophisticated level, in cosmology, if you think about the fact that the universe is expanding and emptying out, the final equilibrium state is one in which it's nothing but empty space. There is no stuff, much less different kinds of stuff at different points in space. So we can come closer or further to being in thermal equilibrium, but the fact that we're not in it is really crucial to our conception of what it means to be us.
Actually, that leads into a potentially fun follow-up, which is a collaborator of mine mentioned recently. People have been putting ideas out there for advanced alien civilizations to avoid the heat death of the universe using various tricks related to black holes or manipulation of free energy gradients. I don't know the details. I haven't seen the papers. So I just wanted to ask, do you think there's any credence to the possibility of any form of technology that could potentially avert heat death of the universe?
I think you can delay it, but not avoid it. I think it's going to happen. I do think that, well, let's put it this way. I can't prove to you that it's impossible to avoid the heat death of the universe, but I am more or less convinced that if you are somehow not precisely in equilibrium, nothing is happening either. I mean, what it means to be a thinking creature, it not only is that you're out of equilibrium, but you're actually doing things that increase the entropy of the universe. And so if you're near the maximum value, you can only do that so much. And so like maybe you could be a completely solid, stable crystal that it never changes. And technically it's not in equilibrium. I still think there would be some probability that you would quantum fluctuate into equilibrium, but you certainly wouldn't count that as a conscious creature.
Actually, have you ever, any of you read this short story of Isaac Asimov, The Last Question? I'm translating from Spanish. I don't know the title in English.
No, I think that is that. I know this. I know the title, but I don't remember the story.
Yeah, it's about that. It's basically the last question is exactly this. Like, can they actually overcome this, like, heat death of the universe in a certain way?
We will all be dead long before the heat death of the universe. Don't worry
Yeah,
too much about this.
I mean, in his universe, the machines have overcome. I mean, we become like a universal consciousness, like the universe becomes a universal consciousness. I mean, actually, that's a good question. You as a theorist, you think like that is possible in a certain way?
Yeah, I don't want to be a party pooper, but probably not. Just because space is big, like if our galaxy were a single conscious creature, it would take 100,000 years for a signal to travel from one end to the other. And so the time scale for moving and doing things, if the galaxy were a single conscious creature, would be, at least hundreds of millions of years. Not that many things you could do. The galaxy couldn't even do a few push-ups before the end of the universe hit it. So,
and there are galaxies which are very like decoupled. I mean, they're faster.
Yeah.
Moving away faster than the speed of light.
But yeah, the galaxies couldn't talk to each other, that's for sure.
If things were entangled before they were expanding.
Doesn't help because you can't use entanglement to send signals.
Exactly, yeah. But yeah, that will need to like break up whatever we know of right now. So, but it may be a way.
Well, look, it's always possible that we just don't understand all the laws of physics. In that case, all bets are off. I can only speculate within the laws that we think we more or less know.
Anyone online wants to say anything? Okay, everybody's very passive online. So actually, we are right to the last question, but I hope there are many more afterwards. And I think we already kind of talk a little bit about this, but I would like to hear you a bit more about your opinion on this. Is it necessary to give interpretations of natural phenomena if mathematical descriptions are sufficient to predict their behavior?
Yeah, I'm not sure about this one. I read this and I wasn't sure what was being alluded to here. I mean, I think that, again, at some level, think about string theory. Mm-hmm. String theory posits that at the fundamental level, the world is not made of little particles that are point-like, but little string-like one-dimensional objects. And when people first hear this, they always want to know, what are the strings made of? And the answer is they're not made of anything. They're string stuff. Everything else is made of them, And I think that this is an inevitable point you reach when you try to discuss the fundamental nature of reality. If you get it right, if you're at the fundamental level, you can't really say it's made of something, right? Or even in a broader sense, you can interpret it as some other kind of thing. It's a uniquely fundamental baseline, rock bottom essence of reality. And so I do think that you can describe it mathematically. You can say like, oh, I'm going to model it as this point in this vector space or whatever with this set of dynamical rules. But that's just helping you predict what reality is going to do from moment to moment. It's not telling you what it is in any deeper sense than that.
Yeah, but at the very least, for example, people believed that the atom was like the last fundamental, base of reality, and then we realized it was not. So we are in a stage in which we feel it's very fundamental, right? But I don't know, for example, what actually, I guess quarks, leptons, and all these like fundamental particles. That's why we don't even know why are so many of them, right? And
yeah.
If there's anything beyond that, or below that, it's like, is there any like an ending goal? It's like, do you strongly believe that there's like a baseline that cannot be like divisible, further?
I don't know about the word strongly, but everything else there, I believe. So, I have no part of me wants to insist that our current best theory is the fundamental one. I think that there's no reason to think that. We can certainly go further than what we have now. But just saying that gives me no motivation whatsoever to say there can't be a fundamental level, or we can't find the fundamental level, or anything like that. I mean, there's an epistemological question. Is it possible there is a fundamental level, but we'll never know? We'll never know for sure, because you could always discover something new tomorrow. But I can imagine that at some point in the future, we know enough about physics to say that what we have as our best theory is a very good candidate for the fundamental nature of everything. Well, we're not there yet, but that's something that is at least a goal worth shooting for.
I think at the very least, the question is more philosophical than physical, right?
Both are involved. You need both. Yeah.
Actually, it's so funny. When I was a child, I asked my mother, what were God's parents? And she told me, okay, he has like a father and a mother. And it's like, but then they have a grandfathers. And then I asked like further and further and further until my mother said, okay, those were created by themselves. And I until now, I still don't understand, I don't agree. It's like, why that?
It's not just you.
A question beyond I mean, there's always another question. What is beyond something, right?
Yeah, and so there's basically two strategies there. One is you invent something that doesn't need to be explained. You claim that there's something, usually God, but it could be something else, that is a necessary being, and it explains everything else and doesn't need to explain itself. That's a very respectable move in theological circles. But otherwise, you can just say, no, there's a bottom. There's some brute facts. They didn't have to be this way, but here's how it is. And we're discovering that by doing science. I'm perfectly happy with that.
Yeah, actually, I think what the people that follow this Gnostic spiritual belief, I don't know how to call it, it's that God doesn't exist, but it will be created. I mean, if the universe is evolving and entropy is increasing, it will reach a level of complexity in which there might be some kind of super conscious that can be like super aware of everything.
It's a free country. You can think whatever you want.
But I want to ask your opinion about this kind of stuff. It's more than what they say. What do you think?
Well, I think, again, I do think that if you're serious about these things, scales of time and space and energy matter. The universe is 14 billion years old since the Big Bang, and we think of that as a long time. It's a pretty old universe, but it really isn't. That's roughly 10 to the 10 years, and the last star will burn out, stop shining about 10 to the 15 years from now. So that's many times. It's 100,000 times the age of the universe. And the black holes will still keep going and radiating, and the last black hole will radiate completely away something like 10 to the 100 years from now. So again, much, much further than the stars. But still, it's finite. And if the universe is accelerating like we think it is, like Sophie, I think you already alluded to the fact that galaxies are leaving our horizon. And so there's a finite number of things we can talk to even in principle. And so if you want to make bigger and bigger conscious creatures, they will, just by the constraints of time and space, metabolize and think more and more slowly than we do. And so there'll be less and less effective time for them to exist. I think the frontier is not bigger and bigger overarching conscious creatures, but smaller and smaller ones that can think really, really fast and experience a lot of things.
Which feels a bit sad, right? It's like humans have a deadline.
Never promised you a rose garden. Yeah.
Anyone wants to contribute to something else? No.
Hi, this is Mihai. As Becca mentioned before, I'm not literate in these things at all, but it's super interesting. And I have, a question from my perspective. How do you reconcile, or how do you view the, human cognitive limits to our interpretations of everything we've been talking about, and our interpretations of consciousness in and of itself, and this whole picture of everything that we've been discussing? It's a bit of a philosophical question, but I think our cognition basically limits our understanding of everything, and as we evolve and we reach better understanding of physics and everything, we sort of expand this, this ability that we have, like learning about new stuff, and we can allocate new interpretations. And it seems like continuous dynamical system where we always find out new things, basically. Thanks.
Well, I think that, again, this is something where I can give my opinion and you're welcome to disagree with it, but I would really want to distinguish carefully the difference between infinite and really big. Those are two different things. And we might be very far away from knowing the fundamental nature of reality, but that doesn't mean it's unattainable just by itself. My own prejudice or my own guess is that there was a phase transition in human cognition when we started thinking abstractly and symbolically, however many thousands of years ago that was, when we started hypothetically thinking about counterfactual future scenarios, representing them symbolically, and therefore giving ourselves a way to talk about the future that wasn't just pointing to objects in the present. And we basically, became Turing complete. We can think all the thoughts that you need to think or that you can't think as a Turing machine. And that I see no reason why that's not sufficient to figure out the laws of nature. I don't think there needs to be levels of subtlety and nuance in the universe that are beyond humans' current capacities. If anything, what surprises me is how good humans have been just in the last 100 years, how much we've learned about the fundamental nature of reality. So my own view is that, the worry is not that we'll never get there, but that we'll get there too soon. And we're going to deprive future generations of the fun of figuring it out for themselves.
Actually, I have a follow-up question. So you think we will reach singularity?
No, because it goes back to, the difference between knowing the fundamental laws of physics and doing things with them like biology or whatever. I think that even though our ability to know the fundamental laws of nature is pretty good, our calculational abilities are dramatically finite. And, Moore's law has been going on for a good time, but it won't go on forever. It can't go on forever. You're not going to make computers as small as atoms. There are not enough degrees of freedom to do that. There are fundamental limits on our calculational abilities. And so we'll get very, very good, but we won't get arbitrarily good. Again, there's a big difference between big and infinite.
Somebody else has I see your question, please.
This kind of singularity stuff is always kind of frustrating because they completely omit things like Landauer's principle and even the second law is completely ignored.
Yeah.
Our intelligence is going to diverge. Well, that comes at a cost. You can't do, arbitrarily large amounts of computation for free. And that almost never seems to enter into the conversation, which is kind of sad. But
yeah, I would agree with that and even just extend it. Like there's a lot of practical limits on things, and that's not to say they cannot all in principle be overcome, but you can't just pretend, that they're overcomable. You have to do the work because there are, like you say, things like Landauer's principle that really do at some level get in the way.
I actually wanted to ask a question related to Michael's question about the limits of our knowledge, and it's an idea that's related to kind of chance versus necessity in biology, which is a bit of an unanswerable question. If we replayed the tape of life, which things would be conserved and which not? I mean, we can work out some things because some things evolved multiple times in completely independent lineages, and so they seem pretty strongly convergent and so forth. And I just wondered, so David Wolpert has written a little bit about this, basically the degree of contingency of human knowledge. So he sort of suggested even something like mathematics, which we would assume that mathematics should be like a convergent thing. So if we replayed the tape of humanity, we should converge back onto the same rules of mathematics. But he sort of suggested actually that may itself be historically contingent. And if we replayed the tape of human history, we might be dealing with a different mathematics than the one we currently have. So I just wondered, what's your opinion on if we did replay the tape of human history, do you think we would converge back on the same mathematics and the same quantum mechanics, or is there a possibility that we would that there is some contingency of historical contingency of human knowledge?
Yeah, I mean, this is a very important and good question, and I don't have super strong feelings about it. I think that it's easy to, I think that there's enough constraints that it's plausible that there'd be more convergence than we might think. Certainly when it comes to the laws of physics, you can say, well, what if we invented quantum mechanics before we invented classical mechanics? I mean, just trying to flesh that out into any realistic scenario seems a little hard, like why in the world would we have invented wave functions and collapsing and entanglement before we knew F equals ma? Like that's just really strange. Or why in the world would we invented general relativity before Newtonian gravity? I think there's a logic to how we actually invent things. There could be absolutely differences in the details. We could have been better at information theory earlier or whatever. But I think the broad strokes, probably there's more convergence in the intellectual evolution of scientific ideas than there is in the actual biological evolution of species and organisms.
Like, I can imagine, for example, if there were to be any other conscious beings, they, for example, can exist at very different scales. So they can experience, for example, quantum phenomena more often than we do, right?
It's very, very hard. I mean, you could cook something up, but the thing about quantum phenomena is they're really delicate. If you entangle two particles, it's too easy to bump into one of them and break that entanglement. That's why it's very, very difficult to build a quantum computer, and you have to do it near absolute zero, right? There are examples in biology where it appears that quantum phenomena are used, but you'll notice that we have to look really hard for them. They're not robust, they're not out there, because biology is warm and wet and noisy, and all of those features make it very, very hard to maintain quantum coherence. So it's conceivable, but I think there's good reasons why it didn't happen that way. It's not just random.
In the biology that we know of, right?
Sure, but again, warm, wet, and noisy, these seem like pretty fundamental things to biology. It's not just sort of accidents of history.
Maybe that's a question also for Stuart, because he
Stuart can tell us.
Extraterrestrial life. So do you think there's a way to predict like this, like a particular scale in which life is more likely to occur, or consciousness? Did you hear, or?
I think I did not hear. I think you dropped out. Sorry.
Oh, can you hear me now?
Now I can hear you.
Okay. My question was, do you think that physics can predict, for example, a particular scale in which life is more likely to occur? You can create some kind of theory for that.
Yeah, I mean, maybe it can. I don't know what the answer would be. Like, clearly, even here on Earth, life appears at quite a number of scales, from viruses up to blue whales or whatever, or to giant forests, maybe. But what to say? Like, if you say not just life, but if you think about complex life, maybe there is a trade-off, like you need to be big enough to be complex, but not so big that different parts of you can't talk to each other, right? Maybe there's an information exchange kind of trade-off that gives an upper limit on how big a complex organism can be. And there's some argument that says, you saturate the total amount of effective, useful complexity in a biological organism for that reason. I have no idea what that would be. That would be fun to think about.
Maybe there's already a paper about that.
Yeah, I think so. I'm happy to be a co-author on the paper that you folks write.
Anyone has any? Yeah.
Hi, this is Becca again. I have a really silly question, but since you just mentioned like the complexity within a single organism, do you think technically within ourselves, our individual cells and components constitute a shared consciousness between like our different neurons and things like that?
Well, I think, again, this is something where there are people who are more expert than me. Probably Christoph Koch is way more expert than me. Part of the idea of integrated information theory is that you can sort of divide up the system at different scales and look for the scale at which there's a peak in the consciousness, right? Maybe arguably when you get a bunch of people together in a mob, it is the mob that is the agent rather than the individual people in it. And so there's like some amount of consciousness or agency in a cell or in an organ, but not as much as in an individual usually as it is usually construed or in the usual context or configuration. So I think that, again, I think that there are probably good history independent reasons why consciousness tends to be localized in individuals. I would love to be wrong about that. There's a million science fiction stories written about group minds and things like that. What I suspect, what I conjecture, let's put it that way. What I conjecture is that there are fundamental limits to that kind of distributed intelligence. I mean, you can certainly imagine distributing functions, particular roles within a bigger intelligence, but would the whole thing be intelligent or just the subsets? I suspect that it's difficult. I would love to be wrong, but I haven't thought about it very deeply.
I was thinking, like, for example, you can think countries behaving as some kind of units of consciousness, right? Because they are collective decisions that are taken and they interact with each other, right?
Absolutely. This is actually a fascinating topic that I just taught a course on
really?
at Johns Hopkins on the physics of democracy.
Wow.
Because
that's so cool.
it's actually a fascinating question how you go from a set of individuals with preferences to something that you call the preferences of the group. And it's not at all clear how to do that, especially because, unlike in biology, we artificially put layers in between, right? We vote, and then we have representatives, and they do something. And what our representatives end up doing might not be the same as the people want them to do. And also, there's all these theorems in social choice theory about how voting is never very good. You can't actually have a system that everyone agrees on. Some people's preferences are going to be not taken into account and so forth. So I think this is actually, there's a lot to be said there. We do talk about countries or races or whatever as if they have opinions. We anthropomorphize them. How good is that talk? How good should it be? I think these are very important questions. And
I would argue, first of all, that countries are much dumber than individuals, because sometimes it feels like babies fighting to each other, like rational individuals interactions could be probably more rational than what countries do, right? It's like different dynamics. And I think some of the reasons why this happens is also like a communication problem, as you said before, right? So it's very hard to convey what we personally think and to make rational decisions as a collective, because we cannot communicate perfectly what we desire, what is best for us, right? Mm-hmm.
I think that's part of it, but also there's another part of it, which is just the idea of rationality in the sense of rational choice theory or game theory posits that you have a set of preferences that satisfy certain very simple criteria, right? If you prefer A to B and B to C, you prefer A to C, okay? It's not at all clear that when countries interact with each other, that they have any rational set of preferences in this sense, or at least that the actions of the country as funneled through individuals voting and then the representatives enacting policies can be thought of as reflecting any rational set of underlying preferences. So again, I think this is a very rich, interesting set of things to think about.
Oh, thank you so much, John. Oh, sorry.
Yeah, can I give my opinion on that? I don't think people voting for someone reflect individual rationality, but rather reflect an evolutionary adaptation of us to want to belong to certain groups that sort of increase or maybe provide the illusion of increased chances of survival, which is why we tend to want to be part of groups, which lead to this. It doesn't necessarily mean that we're rational about it. It's also, of course, it's also dependent on the limited set of choices that we have when we vote, for example. So yeah, there are a lot of aspects there that need to be taken into account.
There are just two things I would say. One is that, the word rational in this context has a very well-defined technical meaning, and you can be dumb but still be perfectly rational. You can have rational preferences that lead you to extinction without any problem, or you can have rational preferences that come out of your tribal allegiances, but they're still rational preferences in the technical sense. The second one is that there is an increasing appreciation of the fact that our rationality is bounded. We don't have perfect information. We don't have perfect calculational abilities. And we don't perfectly update our prior credences using Bayes' theorem. So there's a whole bunch of ways in which you're right, we're not perfectly rational, even by the standards of rational choice theory. But what are we is a complicated and ongoing question.
No, it's fine. Thank you. I was just referring to that particular thing of voting and social belonging. But yeah, there are also these theories of rational inattention where people sort of attribute, they use their cognitive limits to make optimal choices, or what they think optimal choice is in the context of whatever they can pay maximum attention to according to subjective individual preferences, basically. So yeah, I agree with you on that part.
Thank you, Mihai. I don't know if there's any questions online. This is your chance, because I may ask you, Sean. So I don't. We set up this meeting until noon, but I mean our noon. I don't know how much time do you have. There's already 11:30 here. We can continue our conversation. Depends on your time schedule. Yeah.
I don't have a hard cutoff, but I am moving from one apartment to a new house, so I can't spend too much time.
Okay,
I have things to do.
so, yeah. So then I will give the chance of the people online if they want to say something, and this will be the last time, because then we can give Sean the time to to prepare for his moving. No, you're missing the opportunity. Okay, yeah. Okay, so maybe I have one last question, and it's, I think, a personal. I mean, I have actually two questions, but you can choose to
Okay.
reply any of them. This is another question from an astronomer. What do you think dark energy is? Just that, random.
It's the cosmological constant. It clearly is. Don't waste
It
your time
clearly is.
thinking about
Okay,
anything
okay.
else.
It's not a
Yeah.
particle, not a thing else. Okay.
No.
Okay. And
I
there
mean,
was
by
a-
the way, I hope it's not, because my best chance to win the Nobel Prize is if the dark energy is a very, very ultralight pseudo-Goldstone boson. I wrote a paper about that and made an experimental prediction, and if they find it, I'll be famous. But I think it's
wow.
actually just a
Well,
cosmological constant.
I mean, we can root for it. I don't know if we'll make
Root for it. Yeah, I'm rooting for it. Rooting and believing
Maybe
are two different
if
things.
we can create reality, if we think enough about it, it can happen, right?
It's never worked before, but maybe this time. Yeah.
And my last question is something like a personal one. What happened in your life that makes you choose physics?
Oh, I was very young when I chose physics. I was like 10 years old when I started reading books from my local public library about the Big Bang and quarks and leptons and black holes. And I just fell in love with it. And I decided that whatever it meant, that's what I wanted to do for a living. I had no idea what it was to be a professor, to do theory or anything like that. But and I stuck with it. And, I don't recommend that anyone make up their minds about their future trajectory when they're 10 years old. What do you know when you're 10 years old? But it's worked out okay for me.
It works for some people.
Yeah.
But if you had to choose another career, what would you choose?
I whatever it would be something involving thinking and writing. That's what I love doing. I like figuring things out and writing about them or talking about them. Maybe I could have been a mystery novelist, but I would not have been a manual laborer, I don't think.
Oh, well, thank you so much for your kind answers and for your time. It was really appreciated. At least I appreciate this a lot. I hope the audience also appreciate it. Yes, they are agreeing.
Good.
So, I think we reached the end of the questions that we have prepared. So we can set you free to prepare for your move. And yeah.
Got some
thanks
packing to
again.
do. I do appreciate it. Thanks, Sophia. Thanks, everyone. Thanks for
again,
coming.
well, have a very nice moving.
Bye-bye.
They all say thank you and bye. I will stop sharing this, and I think we can also stop the recording.